Here is an explanation for the answer to final exam question number 65 in Physics Demystified, second edition. If you have the printed book, please see page 528. We're talking here about a form of radio wave propagation known as tropospheric bending. Tropospheric bending. What that is, suppose you have two stations located, a couple of 100 miles apart, 300 kilometers, somewhere in that vicinity, although as long as they're over the horizon from each other, no direct line of sight exists. Nevertheless, at certain radio wavelengths, the radio waves will bend in the Earth's lower atmosphere like this, so that over the horizon communication becomes possible. The troposphere is roughly 10 miles thick above the surface of the Earth, 10 miles or 16 kilometers thereabouts. It's where the weather occurs. The index of refraction for radio waves at certain wavelengths or frequencies varies just in a certain way so as to make this bending possible. The index of refraction is higher where the air is more dense near the surface and lower as you go up in altitude, therefore causing refraction of radio waves at certain wavelengths. And the question is asking us which of the wavelengths given, 2 kilometers, 200 meters, 20 meters, or 2 meters, would we most likely expect to find this phenomenon, tropospheric bending, taking place? Well, it tends to take place at wavelengths of a few meters. So 2 meters, which corresponds to a frequency of roughly 150 megahertz, would be the wavelength that we would most likely find this phenomenon taking place. And that is choice D.